the basic concept of signals. And we distinguish between continuous time signals and discrete time signals. Also, it was explained how we distinguish between periodic and aperiodic signals, and continuous and discrete time signals. Today, we're going to discuss the symmetry of a signal. Why should we discuss the symmetry of a signal? Because sometimes when you know that the signal is even function or odd function, it will help you to analyze the signal in a shortcut way. And there are many applications that we use the symmetry of signals to make the analysis simple. So let's just look for the first type, even signal. What's even signal? In general, you look at even signal, you will see it's symmetric about the vertical axis, y-axis. So if you look here at the first example, you will see that there is a triangle here to the right of the vertical axis. You look at the y-axis exactly like a mirror. You'll find reflection there, same magnitude, the same interval of time. So we call this even signal or even function. And the mathematical equation that expresses that x at the time negative t equal x of t. What does it mean? It means if you pick, for example, here at, let's say, at 2, and you look for the value of this function, you'll find that the value of this function is the same when t is equal -2. That, what does it mean? X -2 is equal x2. The same value when you flip the sign of the time. And it happens everywhere, not only at one point, every single point. That's the proof that this is even. The same thing will be applied for the discrete time signal. But instead of using t, we're using n. So x n and x of -n, they are equal. So in this example, you will see when n equal 2, the value here is the same when n equal -2. When n equal 4, the value is equal 0. When n equal -4, the value is equal 0. It's symmetric again about the vertical axis. But observe something. At the vertical axis, you can have any value. It's the mirror. So it doesn't have any image. The mirror doesn't have an image. So it doesn't matter. The one on the vertical axis, don't look at it. Just look to the right and to the left of the y-axis. So that will be the even function. The odd signal, when you look at this triangle, if you make a reflection on y-axis and another reflection on x-axis, you will get the same signal. So the odd function is equal to 2 reflections, one on y-axis and one on x-axis. Or shortly, you can say it's symmetric about the origin. If you draw a line passing through the origin, you'll find that both parts are symmetric about the origin. And mathematically is x of -t is not equal xt like the even signal. No, it's equal -x of t. Means that will be equal in magnitude, but you will add just negative sign. Like what? For example, look at this value that we take it last time. Let's say equal at 2, it has this value. Say equal 3, 1, whatever. When you go at -2, you will not find the same value. You find the same value, but on the other side, on the negative side. So if it's positive, it will be negative. If negative, will be positive, but the same magnitude. That's how you look at it. The same thing is implemented for discrete time signal. For example, let's look at n equal 2. Let's say that the value is equal 1. So when you go for n equal -2, the value will be equal -1. It's the same magnitude, but you flip the sign. Again, don't look at the one at the origin. We don't look at it. So that will be an odd function. Yes.
Someone commented on the stream.
Oh, there is a problem with the audio here. Yeah, I fixed it. There was a problem and I fixed it. Okay. So that's the even and odd. In fact, any function, any signals, continuous time signal or discrete time signal, you can express a signal into two components, one even and one odd. Any signal. The question is, can I do that for even or odd function? You do it to any function, even if it's not even, if it's not odd. I'm talking about if you have a function, it's not even, it's not odd, and you want to find when you extract the components, the even components and the odd components, you can do that. The expression will be like that. For continuous time signal, any signal x of t is equal the even component plus the odd component. Anyone, any function, any signal. The same thing for the discrete. X of n is equal to n, the even component plus the odd component. How can you get it? How you can get the even component and the odd components of any signal? Very simple. For continuous time signal, if you want to extract the even or the odd part, you got to do something. You have the signal x of t. Find x of negative t. We call x of negative t time inverse. When you make the time inverse, you get x of negative t. So now we have two components. You have the original signal x of t, and you have the other one, x of negative t. Then what you do? If you add them divided by 2, you get the even component. If you subtract them divided by 2, you get the odd. Is it applicable also for discrete time signal? Yes, for both. The same equation. So look at the equation. When you get the even part, you add x of t and negative t divided by 2. When the odd part, you subtract. But you subtract what? First, you have to put x of t always in the front. That's you remember. Let's take an example. You have here expressed in the diagram and also the function here. It's t from 0 to 1 and 0 otherwise. We want to find the even and odd component of this signal. First, what we're supposed to do, we get x of negative t. So how we get x of negative t? X of negative t, you can get it by flipping everything. What do you mean flip everything? Just make reflection on y-axis. The part on the positive side will come to the negative side. The part to the negative side will come to the positive side with the same magnitude, the same integrity. I'm just saying without any mathematical expression, in an easy way, how you do it practically. And then you can express it mathematically if you can do it. So this one from 0 to 1, and the height is 1 triangle. So you have 1 will become negative 1, and 1 at 1 will be 1. Only it will be like reflection like that. That's x of negative t. So how you do time inverse? Reflection on y-axis. You don't change any amplitude. You don't change any, the interval, the magnitude of the interval does not change, but only the sign of that interval. Instead of 1, negative 1. Okay, and then what you do? Then you add them. If you want to get the even, you add. And when you add, you divide by 2. You can do it in 2 steps or 1 step because we have to be fast. So let's find the even function. So I will have x of e, the even. I'm going to add. When you add now, 0 and 0 is equal 0. Divided by 2, you have 0. And then you have here a triangle, and it's from 0 to 1. Anyway, this is 1. If you go here at 1, the value is 0. So 1 plus 0 is equal 1. 1 over 2 is equal half. So at 1, instead of 1, you are going to have half, 1 point. So you go there, this point. Just take the major points in the graph to make it easy, and then you connect it to a straight line. Still straight line. Let's look for the other side. At -1, the value at t equal -1, that's the time axis. At t equal -1, the value is 1, and at t is equal 0. So what is 0 and 1? 1. Divide by 2, half. That's half. That's the function. See, yes.
So it kind of makes sense, but at least in terms of like the function that's getting like 100 negative, if you're looking at x as negative, plus 1.
Why you are adding 1 plus 1? You are adding at t equals 0, the value equals 0. At t equal -1, at t equal -1, you are adding at every corresponding time.
So you're doing it at t equals 0 because of the original.
Yes, I'm adding the original x of t and x of -t. I'm adding both. So how I got it? I got it like that. I add xt, the original one, plus this one time inverse, and divide by 2. It should be at every single point, but just I'm taking the major points. Yeah, to make it easy. So when you look at it, you got the even one, right? Let's get the odd one. How we get the odd one? Well, you subtract. So now let's subtract. You have 0, and let's take from the right to the left. At t equal 1, at t equal 1, x of t is equal 1. And this is 0. 1 minus 0 is equal 1. Divide by 2 equal half. So if you have half and 1, so it will be half. And it will be the same. If you are adding the same point here and the same point here, will be just everything half. I'm subtracting. Now you go subtract from this one. At t, I'm subtracting xt minus x negative t. So at t equal -1, the value is equal 0. And minus, I'm subtracting. The value of x of -t is equal 1. So what is the value? -1. Divide by half. What you get? -half. So I have to go. That's -half. That's -1. So at -half, I have the point. So what you got? Odd function. How I did it? I just subtract xt minus x -t and divided by 2 at every single point. And you can express this by equation like here exactly. Everyone you look at it, you do it. You can do it by mathematical equation too. But just to like to show you graphically, so to make sense. Yes.
You explain why you put subtracted 1 from 0?
1 from 0. Yes, this one in the at t equal 1, x of t is equal 1, and x of minus -t at 1 equals 0. So in this part, 1 minus 0 divided by 2 is equal half. That's what I got here. Yeah. And the other side, you have 0 minus 1 will be -1. By 2 is -half. And 0 minus 0 is 0. It's the same, no change. Pardon me?
It's the y value for the
Y
one.
value?
Yeah. Or the t value for 1.
Oh, you mean, okay. The value of the function at t equal 1,
Yeah.
and the value of the function at t equal -1. Yes, that's what I did, yeah. I don't want to call it y of t because we will have x of t, y of t. So this is the function x of t. Yeah. And the x-axis is t, and this one x of t. So that's how you get the odd and the even function. You can do the same thing with the discrete time signal. Here you go. You have a discrete one. That's x of n. And that's the equation given and the graph. So when you look at the graph, if you can see it, you can make it bigger here. at n equal -5, the value is 0. At n equal -4 is 0, and so on till at n equals 0 up to n equal 5, it's equal 1. That's a discrete time series. So it's defined over the interval from -5 up to 5. I'd like to remind you by something. If I ask you how many samples in this signal from -5 to 5, how we calculate it? It's easy, you can count it now, but what about from -100 to +200? So you should know some kind of equation. Can you guess about the equation? From -5 to 5. Subtract 5 minus -5 equals 10. How can you count it now? Count it, see if it's right or wrong. How many samples? 11, right? So you will say TF or NF, I'm sorry, NF, the last one, NF was equal to 5 minus N0 plus 1. Why plus 1? The one at Z, exactly, one at Z, yeah. So always keeping in mind, this is the number of samples. All right. It doesn't affect the even odd, but just it will help in the future. So now I want to find the even or the odd. So what I'm supposed to do? I'm supposed to get n x of -n. So x of -n, I'm going to make it here, but just a little bit, maybe smaller. That's n. So at negative, how you do the -n? You flip it. You flip it. You make reflection. Remember that on the vertical axis. But at the vertical axis itself, we don't make any change. So at n equals 0, the value was equal 1. Make it 1. I'll just make it shorter here. I don't have space. And at 1, it will becomes -1. And see the value at 1, it was 1. So at -1 will be 1. From 1 up to 5, just to make it to get short, -3, -4, -5, all will be equal to 1. I'm making the reflection for the positive sign. What about the negative sign? The negative sign, -1 become 1. It will be 0, 2, 3, 4, 5. So can you see it? You keep the 1 on the vertical axis as it is, and then you flip right to left, left to right by the same value. So, and you call this x of -n, and this one x of n. Then I want to extract now the even component. What should I do? I add and divide by 2. So that's simple. I have 0, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. At 0, I keep it as it is, 1. Now, at 5, 1. At 5 here, I mean when n equal 5, at x of n is equal 1, and here is equal 0. So 1 plus 0 is equal 1 divided by 2 half. So obviously, I'm going to have half all this samples, right? Because all the same. From 1 to 5, the same. 1 plus 0 over 2 is a half. The other side, we have zeros on the top in x of n, and x of -n, you have 1s. You add again 0 and 1 is equal 1 divided by 2 is equal half. So what you're going to have? Half. Symmetric about the vertical axis, even segment, right? You have any question about that? It's simple. What about the odd? Let me just write this as the even. How that even? N. What about the odd? Simple. We're going to subtract. Just we'll do the same thing. -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. At 0, no change, which is equal 1. Make it 1. Then you will go there, you subtract 1. I'm subtracting now the right-hand side. This is 1, this is 0. 1 minus 0 is equal 1 over 2 half. So I will have half like in the one on the top. All right. The second part here, 0 minus 1, -1 over 2, -half. So I'll have -half, -half. So as you see, it's symmetric about the origin or to reflection. You got out. That's the out. All right. So we're done with the even signal and odd signal, and how you can decompose any signal into two components, one even and one odd. And when I upload this one, always when you see checkpoint, it means you have to, or you should solve these problems. So you will make sure you understood the concept. So you'll find that checkpoint, some simple examples, and sometimes they have some idea, and you'll find that the answer on the bottom here. When the answer is easy, just about the answer. So you just check yourself by these two simple examples. It's a very simple topic. Any question on this one? Yes.
Could you show the algebra way for the previous question? Go down a little bit. That's down all the way. The question we just did. Could you show?
Oh, the discrete? Yeah. Okay, let's just pick any signal at we're looking. Let's say we're looking for the even. So in the even, I need to add and divide by 2. So check one point, for example, at n equal 4. What is the value of x for? That's 4. 1. What is the value of x negative 4? I'm sorry. Yeah, x negative 4, yes. I'm looking for x negative n here. So when you look at, that's here, 0. Well, let me just explain it for you. What does it mean? Sometimes the software is annoying. Okay. You have two functions, x of n and x of negative n. So if you make a table, you will say n, x of n, and x of negative n. And this way, you will not be confused, because you will think at n equal negative 4. No, I'm talking about n let's say what you're going to do. You have from n equal negative 5 up to n5, right? But you don't have to do the all points every time. I'm just going to pick like 2 points. I'll take at negative 4 and at 4. When n equal negative 4, you look for xn. What is the value of n when n equal negative 4? The value 0, right? So you put in the table here 0. And now we want to find the value of x negative n. You can call it, if you not to make any mistake, call it y of n. So we want to find the value of y of n when n equal negative 4. You go for x of negative n, which is, I call it now yn, and use n the same value, negative 4, and the table negative 4. So what's the value of yn when n equal negative 4? 1. So you go put 1. Let's look for 4. At 4, at n equal 4, the value of xn is equal 1, and the value of y of n is equal 0. Now it's very simple. If you want to find the total for the even, you will say that's x even of n. You add 0 plus 1 over 2. You'll get the half. 1 plus 0 is equal 1 divided by 2 is equal half. And the equation here, just to put it on the side, is equal half x of n plus x of negative n. So that's the equation. And this table will make it easy for you. You can make this table like that, and you put here x even, and you put on the bottom another x odd, and you get both in one shot.